crazy guy. This weather, you have better weather than me in Spain. I came from Spain, and you have better weather than me almost in November. I can't believe it. I can't believe that. Okay, so I'm from Ramirez. I work in Telefónica. It's a Spanish big teleco company. And I'm here to talk about the bad guys. Because this talk, it's going to be something like if you have a new technology, you can be sure that somebody's going to use it to scam or to cheat someone. That's for sure, 100%. So in this talk, we're going to talk how to use AI, machine learning, autoencoders, to make a further steps to accomplish the classical scam for the CDO. You remember that, right? It's an email that says, please send some money to that account. So. But this time using image, video, and even audio. Okay? So first of all, this is Pablo. Pablo is supposed to be here with me, but he's stuck in Santiago de Chile. You know that there is some riots over there. So he wasn't able to take the plane, so I'm here alone. He's a very known security researcher in Spain. He has a lot of books written by for pen testing or Kali Linux or everything related with security. This is Enrique. Enrique Blanco is the mathematician mind behind all of this research. Okay, he's astrophysics. And this is me, the geek, the freak, the guy that's going to use all this technology to try to scam a CDO or a CEO from a company, right? So I'm from Ramirez, as I told you. Was working for a while in USA and spent almost my time in the Comic Con in New York. And I wrote a couple of books related with Docker, machine learning, security research. Okay? Okay, so what is about? I'm going to make a glimpse about AI and machine learning. Okay, I only going to scratch the surface. I can't go deeper. I don't have enough time to go deeper in autoencoders or in machine learning. So I'm going to scratch the surface, but I hope you get a lot interested on that kind of stuff, just to go deeper later in your own research. Okay. So first, I'm going to talk about news and fake news, AI, machine learning basics. After that, I'm going to talk about how attack and how to defend any attack based on machine learning, and how can we do that. I have a small demo over there in this computer, so I'm going to show you how it works. But the base of all the talk is the scam fraud to the CDO, okay? To CEO or CDO. Okay, so take your notes, take your calculator. Let's go deep inside the autoencoder's herd. So I'm joking. Let's talk about porn. Okay, so that was the first things that the people did with all this technology. Take a face and put it on pornography films, right? So this is the starting from Star Wars, and somebody took the face and put it on a film, on a porn film, right? So it is what it is. In internet, everything is about porn, right? So that was the first use that we saw with deepfake and deepfake using faces and video, okay?
On $8 an hour in New York City, and foremost in all of our minds has been.
Okay, this one is very known. This is when I think it was the MIT use a Obama film video, and they only changed the lips. They didn't change the face. It's a new approach. It's a good one to have in count because it's pretty perfect.
On $8 an hour in New York City, and foremost in all of our minds has been the loss and the grief
it's really
felt by the
complicated
people of Orlando.
To check if this is real.
Most of us don't get our
or not
healthcare
real,
through
right?
the marketplace.
And this is scary. I found this one not too much time ago with Jan Nicholson and Tim Curry, and it's awesome. It's awesome. How can you fake? How can you put another face into another motion or another video, right? So this is the base for the scam CDO fraud. We are going to get our CDO face taken from a lot of video on internet. I'm going to try to cheat somebody to make a transfer, to transfer money to another account in another country. Okay? Forget the email, forget the text. We are going to use image and voice. And this is really important. The impact of fake news is really, really big. Look at this news. That one happened with a Twitter hack user. API from Twitter and start to post a lot of fake news about the stocks, and it was a big mess, right? So it's getting bigger, and the fake news is a thing that we need to take in consideration for the future or right now, right? Okay, so let's talk a little bit quick about AI and machine learning basics. This is not a new technology. Everybody thinks that this started yesterday. It started in the 50s. Even Alan Turing, you can see this phrase here, he said that is everything in AI, because everything in deep learning is based on experience. When you start to learn something about machine learning or AI, for example, using reinforcement learning, you are using this phrase. You are making action, you have a reward, so you are learning from the experience, good or bad. So it's awesome how Alan Turing predicted everything more than almost 70 years ago. Okay? So this is not new. But what happened now? We have the computational power to embrace this technology, to go higher. So that's the point. Right now, we can optimize all those algorithms, all those theories, but in the practice. So we can use a computer and put it in the real world. Okay? So I'm going to talk a lot about a model. A model is no more than a mathematical representation of a real-world process. Okay? Just that definition is fine. So, and with a model, you can use an algorithm. That algorithm is the main base to learn. Learn is the training. I'm going to use a lot the training word too. Okay. Okay, an algorithm. No more than the step that you need to perform calculation or processing to accomplish a model. That's an algorithm. Okay. I can't go deeper, so that's enough for the algorithm. Okay. Supervised learning. Here, you only need to take in consideration this part, the labels. Okay? Because here, you know exactly the expected output. You're going to take, for example, apples and orange, and you know that the output will be apples or orange, because you have all the input labeled. Okay? So you can compare here. You are doing a classification here. So you are using labels. You know exactly the output. You have expected output. So here comes the unsupervised learning. It's the same, but this time you don't have the label. So everything I'm going to talk about today is based on unsupervised learning. How it works? This time you don't know the output. So you have a lot of inputs, and those inputs are going to be, let me say, like a cluster or in a group by features. So you need to figure out which features are common between them. Okay? So after that, you will have some characteristics of some features that you can take for your own research. So this is the base for all the deep learning of the deepfake that we are going to make today. And of course, the neural networks. The first neural network was presented in 1950 by Frank Rosenthal, and he called that research the perceptron. This is a perceptron over here. In fact, it's a really, really simple definition. Okay, you only have a couple of inputs, weight inputs, and you have here a summatory, and an activation unit here. So it's no more than take weights, sum, and see if that operation activated something after that. Okay? Of course, this is only the unit. You can put all together using different layers to get a multi-layer approach. So you having a big computational power. You have a big algorithm processing, right? So this is the base for all the research here. After that, you have the deep learning. In deep learning, you are using a specific neural networks called convolutional neural networks, okay? It's really complicated to explain deeply here that definition, but more or less you can have a glimpse here about how it works. So because, by the way, the convolutional neural networks are focused mostly in image. They are the best tool for processing image. So you have a main image here, the target image. You have a set of layers here. And after that, you have a calculation. You can see if this picture is a car, it's a truck, it's an airplane, it's a monkey, or it's whatever, right? So every layer make an action. This is the convolutional neural network layer. So it takes the picture and make a small processing because this layer used to be a small part from the main layer, not the whole image. Okay? So the ReLU is the activation layer. So it's like a template. So if the template fits with the convolutional layer, okay, we have an activation, so we can go on. And go on, we can repeat the loop, and here we have a pool. Pool is no more than a layer to compress the information and make the image with a lower resolution, sorry. And we can repeat those steps over and over after we got the output, right? Okay, so no more chit-chat, let's talk about attack. How can I use all this technology to make an attack? Of course, the phishing. You know that? I think it was 1 month ago in my city. I live in Valencia, in Spain. We have a case, an awesome case. In the city hall, they got an email that said, I'm the manager of whatever. Please send $4 million, euros, this case, to this account in China. Okay, so the person in charge of that operation did it. So took that email and made the transaction. So come on, $4 million to China? Something's wrong here, right? So, but they did it, and it happened all the time. And it happened only using a freaking email test, because that email came or was very similar to the source, to the name of the manager was exactly the same. The person in charge didn't check that was exactly the email, the full address of the user, so they did it. And you know why it happened all the time? Because it's not your money. If it were your money, and probably you're going to think twice to make that transaction, right? But there is a lot of red flags. China, 4 million. Come on, ask. No? It happened all the time. I was working for 3 years in USA. I know, I was working integrating different companies into a bigger one, and I saw this, I don't know, I think more than 100 cases. It happened a lot, but what happened? The company never made public that because it's not good for the company. If you say that you lost for 1 million, 2 million in this scam. No? So there is more fakes that you expect about this. So Fry here is right. OK, so there is another concept, the generative model. Okay? The discriminative model is very simple. It's like I told you before with the supervisor model. You are going to organize different points using a very, very, very big boundary. You know exactly what is this and what is that. But with generative, look at the term generative, generation. You can generate data. You are going to generate information. So that's awesome because it implies, I'm sorry. OK, it means that you can, sorry. I got it. OK. That implies that you can create something from scratch. For example, you can create fake image very close to a real image, but doesn't exist. So right now, you even can create an Instagram profile that the person doesn't exist, the dog doesn't exist, the cat doesn't exist, and the background doesn't exist. In background, I mean, for example, a mountain or a bed. And you can create fakes, a lot of fakes models using this one, the generative model. Okay? So we are going to use that. And how it works, instead, use specific points to share, to divide, to split the information. We are going to use the probability. So we have another, with that, we have clouds that we can use to, OK, more or less, it can fit more or less using a percentage. OK? So I'm going to go deep later about this technology. OK, so inside the generative model, we have two technologies or two approaches. The variational autoencoders and the generative adversarial networks, the GANs. That's the title of the talk, right? GANs. So we are going to use both. What is an autoencoder? We need to know what is an autoencoder before the variational autoencoder. Okay? So an autoencoder is no more than a technology, an algorithm that converts the image into, let me say that, numbers. Okay, you have an image, so it's you convert all this information into a vector, into a matrix of information. So for you and for the model and for the algorithms, it's better to manage that information. They can. So if you have numbers, you can see better if something changed here, if the face moved to that direction or the other direction. So you need to check the numbers, not the pixels. If you're going to check the pixels, you're going to need some kind of algorithm, of vision algorithm, to check the difference, right? So that's more or less, yeah, from the surface, what is autoencoder, okay? You have an input data. After that, you have an encoder that decode all the information into a vector. It's a low-dimensional representation. It's a vector. It's a matrix with a lot of numbers. And after that, you must be able to reconstruct that information into the image again. You will never get the same image. You have a loss function here because you have numbers, and based on the numbers, you need to create the original image. That's almost impossible, but close, really, really close. Here, I don't know if you see very well, but nah, there is not enough resolution. OK, don't worry. But here is a perfect image, and here is a reconstruction with some small changes, right? OK, so what is a variational autoencoder? OK, you know what this autoencoder is. So now it's almost the same, but this time we put here this one, a Gaussian distribution. A Gaussian distribution is no more the probability distribution. Remember the image that I put before in the other slides? Instead, to get one pixel or one position, we are getting a probability that pixel can be or not from that image. So we have a range. We can play with that. No, that's the main point. So using that, you must be able to accomplish the same. Put all the information in a vector, use a decoder, and have a reconstruction of the main input data, in this case, an image. Okay? So this is a variational autoencoder. I'm sorry if I'm going only for the surface, but I don't have time to go deeply. But these are the main pillars of the research. By the way, we didn't invent anything here. We take all the information for the internet, and we take all the tools for the internet. We only make some changes on the code and put it all together. So if we can make it, anyone can do it, right? And that's the main point. This is the big discovery of the inside the machine learning, the GANs. Okay, Ian Fellow is the master of the AI right now. Invented this technology one day, having some beers in a bar. So he wrote in a napkin more or less this scheme, and after that he broke everything in AI, in machine learning, right? Okay, so why? Because this is a fight game. What you have here is no more than a deep neural network. You have here another one. So what's the objective? What is the target of this one? The target is, if you have real sample here, you are training this neural network based, for example, in a database of personalities, actors, or real people, right? And you have here another neural network, or deep neural network, using a latent space, whatever you want. So, for example, I don't know, different kind of color for the skin, for the air. And you are trying to generate fake samples, fake images. In this point, they fight. This one tries to discriminate the information for that one. So it's like a filter. OK, so for example, using the same example with image, I generate here an image, a face. And here we have a couple of real images. So that fake image, when the discriminator gets that image, say, OK, it has eyes, it has lips, a mouth. OK, so it fits. It's more or less, it's almost an image. OK, so it passed the test. OK, so think about this. Focus on computer security. OK, it's awesome. I think every research must be focused on that, because here you can, for example, put here malware code against a antivirus code and fight together and try to find if a real code or not, right? So this is a very interesting approach that I think we need to go deeper, because GANs are very useful for the cybersecurity. OK, so that's the main point for the GANs. And how we use the GANs? We took Pablo's picture for the training. For the discriminator, remember, discriminator is the one who say, OK, you're fine, or not, you are not fine. And that one is the fake image that we create using compression and latent space that I told you before. So we have a real Pablo or not, or a fake Pablo. After the training, we use random noise to more or less don't have the same Pablo's image. So just an approach to Pablo's image, OK? Not the same. So after that, we have the same, a real Pablo or a fake Pablo. And what we did with that. OK, before the video that I have ready over there, look at this. The risk using GAN, the first one is this one. Waiting. And trust me, you are going to waste a lot of time waiting the training. Because if you don't have, but if you have money, you always can rent a computational cloud, and probably you're going to wait less hours. But it's a long, really time. You can have the Chihuahua muffin effect. Okay, so you can get confused with a Chihuahua or it's a muffin. So it happens all the time. Okay, change the Chihuahua and the muffin and put, I don't know, anything, a car or a truck. No, it's more the same. So that's the point, right? And this is always happen. It's really complex. Tweak the training, the parameters, the bias. It's not easy, right? OK, so we use this computer over there. It's not a big computer. It has 16 GB. But the main point is that one. We use an NVIDIA Quadro P600. It's not an awesome GPU card, but it's more than enough. And we use this software to set the base for the research. OK?
No me merezco menos. Vengo a hablar del invento de los últimos 2-3.
OK, this is Pablo's face. That was the first test. OK, we got the Pablo's face and put it on a famous comedian in a famous show in Spain. No? So that's what we get. That was the first approach. OK, it's not very good.
No me merezco menos. Vengo a hablar del invento de los últimos 2-3 años, esta estupidez que se acaba de inventar, que son los límites del humor. Vamos a ver. Yo nací en...
They are real. Do you want...
OK, sorry. The next step was train with another face. We used the Enrique face against the Mourinho face. OK, I'm going to put this video here, but it's not very good. You will see a lot of failures, okay? But I wanna show you what happened here. Look at this. Second.
They are real. Do you want other
Can
real?
you see here?
I'll give you a couple more real.
It's more or less
in the
blend
last
between
7 years,
Enrique face and Mourinho face.
The worst
but you can
position
see
of Manchester City
how
in the
we
Premier League was fourth.
Put the face. Can you see the?
In the last 7 years, Manchester
mouth,
City was champion twice.
Teeth. Right.
And if you want to say,
okay, but we were starting. It was a good start. Okay, so these are the steps for make that approach. The first one, face detection and extraction. We can use videos from YouTube, from internet, or from your target, whatever you want. Okay. After that, in this sample, we use 3,600 faces to this demo. Okay, and almost 3,000 for Enrique. Look at this. Let me see. 1 second. I have an animation here. Okay, got it. As you can see, we tried to record a video using the same faction of Mourinho, the same movement, just to fit better when we put all together, right? So the next step is training the VAE. Okay, so this is okay. I'm going to go quick. We have the original image, we have encoder, we have vector-based decoder, and the reconstructed image. Can you see here that it's different? It's not the same. It's blurry. It's different, right? But at least you have here all the information code in numbers, in math. Okay, so for Enrique and Mourinho example, we use this is not the good approach, because here we have an encoder for the Enrique face, and we have at the end we have a decoder using the Enrique face, so we can put them together. We can mix them. Okay, so you need to unify the encoder for the image A with the image B. Now you have everything mixed here, and you can choose for which one do you want to go, for the Enrique face or the Mourinho face. So you can get this one. You can see here, it's not, I need more resolution here, but this is the output, okay? It's a blend between both of them. So this is the scheme for the VEA, okay? These are the original image from both of them. This one is the image after the decoder A, here. This is decoder B, and this is the blend, the mix. Okay, so this is the approach. Here you can see better the change, right? You can see the fusion here of both images. So that's the root of the research. Okay, how we did it? We use that computer, as I told you before, that hardware, and which software? We use all this software: Anaconda, TensorFlow, OpenCV, DLib, pitch-to-pitch, and CUDA, right? And the driver for the GPU, okay? So OpenCV, of course, for the image processing. The DLib is for this one is one of the more important because it's for the face faction detection. We use that one. So as you can see, everything is on internet. Okay, we didn't embed anything. Okay, so it's time to meet Chema Alonso. Chema Alonso is my boss. I don't know if somebody knows who is Chema Alonso, but he's the CEO of Telefónica in Spain. So he go to any meeting with all the big bosses of the company using this, the hat and that kind of shirt. Okay, he doesn't use the typical business dress, right? So this is me with Kevin Minnick and Chema. So I put here this one because the hat is very tricky, but we wanted to use it in our demo. So let's see how the neural network can manage the hat too. Okay, so for the extraction of the fraction, as I told you before, we use the DLib library here. We took 1,700 frames of the original video. As you can see here, we took all that information, using dlib. After that, we trained the model using pix-to-pix TensorFlow. It took 3 days in the computer. Okay, let me say that if you have Azure, or if you have Google Cloud, or if you have Amazon, you have a big, awesome tools to make this better in less time, but you are going to pay a lot of money on that, a lot of money. OK, after that, we have the model. So we need to test that model. The first thing was reduce the training model. So we need to get less pixel definition just to make the computational less complicated. Freeze the model to a single file just for the snapshot that you have some points to recover if it's in case. And use a webcam image. So why? One second. Why we use the webcam? Because our final target, our final objective is use something like a Skype connection with somebody and say, hey, I'm Chema Alonso, I'm the CEO of the company. Please, can you make that transaction to that account in the Bermudas Island using Skype? So the person is going to see the CEO in the screen, no? Because that's the point. Please take a look to the Chema Alonso's voice.
What pressure. Well, hello, hackers. How is it going? It's going very well. 7 a.m. This is personal data, and this is something that should be protected and is under the control of our customers. And we need to take.
OK, this is the Chema's voice. And this is the voice that we reproduce.
Hi, Luis. Are you available to handle an international payment of $15,000 this morning? Please find a way around it.
OK, it's not exactly the same voice, OK? But it's close, right? Remember that we use that computer, only that computer and Azure. This is important. For the voice, we use this technology, the neural text-to-speak from Microsoft. It's an awesome technology. So instead, the old technology, right now, you have only to input some text. At the end, you have a voice based on the training that you put here. So you can put here any type of voice, your boss voice, and you're going to get an output close to the source. Okay, so that was the tool for the voice. How does it work? Microsoft Custom Voice, it works in the base very simple. You only need to get .wav format, extract the audio from the videos, and get some files, and put all together, right? So after a training, we did only 2 hours training. So let me say something here. Can you imagine what can you do after the demo? It's a very simple demo. But after that, can you imagine what can you do using a lot of computational power from the cloud? Can you imagine that? If you have enough money, you can do whatever you want, whatever you want. OK, so right now, we wasn't able to make a program that you only need to talk, and the programmer changed the voice to another one. So what we did, we used the Google Cloud Speak-to-Text API. So you need to type the phrase, and the algorithm is going to change and make all the processing and reproduce the voice using the fake voice from our CEO. Okay? So that was the training. The training and the action for the demo that you want to see now. OK, so that's it. We have everything. We have all the machine learning. We have all the tools. We have our encoder. We have everything. Put it all together. And let's see what happens if we put it all together and focus in the CEO scam email, right? OK, let's go. Let me show you the demo. It's pretty simple. It's only the image. I can't use the voice because I need connection to internet. I need the cloud. So I'm going to show you how close is the image impersonation. OK, let me see if it works. OK, you see? OK. I'm going to take less than a minute. It's going to activate the webcam. So you only need another computer here or another terminal using the text-to-speech API. You can type, hello, my name is Chema Alonso. Can you make, so press enter, and you can fake the same text with your lips, okay, more or less. That was the demo I'm going to see. Okay, so here, I don't know if it's going to work very well because the background, but let me see it. Okay, can you see it? Even the hat is perfectly located over his head. So if I open my mouth, can you see it? The movements. Okay, it's not perfect because, as I told you before, we are using a very simple configuration, very simple hardware. It's that computer. So, but if you have money, you can get better results for sure. Okay, so we used this, and we thought, okay, we have the image, so we only need the voice, no? Okay. Okay, we have the image, we have the voice, so let's go to scam the CEO, okay? Probably I'm going to get fired because of that, but I don't care. I can find another job. Okay. Look at this video. We put all together using something similar to Skype. I don't know if you can read. Luis, I tried to call you, but I can't reach you at the moment. Can I call you? Are you available now? Can I phone you? Can I call you through Skype? Okay, sure, let's go. So Chema is calling. It's not Chema, it's me impersonating him.
Hi, Luis. Are you available to handle an international payment of $15,000 this morning? Please find the way around it. I'm currently in Las Vegas and I'm very busy. Use this IBAN number for the account where the money has to be sent. Take note of it. Yes, 9121000
Okay, it's enough. Okay, it's not perfect. You can see that it's not very good definition, but we put some sound at the background, like noise, like that, to make it more real, right? So, okay, this is the attack. Let's go to defend. It's almost impossible, but let's try it. Okay, using test is pretty easy. You can use the natural language processing to detect if a news is a fake or it's real, just to check in the test. It's not very complicated. You have a lot of tools here, like this one, to detect fake news. It's really easy to do it. But let me see. The more information about how to do it with tests, with Facebook, from web page, using web scraping, that kind of things. But this thing blows my mind. I love that. I saw a research over here, somebody that say, hey, I can detect fake videos using the blinking or the frequency of the blinking of the eyes. Blinking of the eyes. So, come on. We are in Blade Runner or something like that. Yeah. So, they say that the frequency and the times that the eye is blinking, using those parameters, you can say if an image is real or not. So we make a small program, and it works. It used to work, but what happened? That the bad guys are making now better videos using this technology to fake the eye blinking detection. So it's like cat-mouse game, right? So this is the main research. It used the same tool that we use to attack convolutional networks, VAT, or everything. No? So we are in Blade Runner right now. I think even the JR is correct. This is the same in JR as this one. And they use the eye detection just to see somebody was real or not, right? OK, so how it works. I don't have enough time, but I'll go quick. Number of blinks, blink speed, duration of the flicker, and maximum flicker separation. Okay, the frequency. So we have this Gaussian classifier here. Look at this. This is the blink rate. And this is the blink duration. If your research of your data fits here into the Gaussian classifier, this was a real video. But it fits outside, probably it's a fake video, because the blink rate and the blink duration. OK, so just to wrap up, Fooling people is very cheap and very easy. AI and cybersecurity go hand by hand. This is the future, this is now. So if you want to go further in cybersecurity, you need to get some notion of some basic of machine learning, for sure. The boundary of the AI, we don't know. We don't know what's going to happen in the future. And the knowledge and the awareness, as Barack Obama said here in that phrase, are the basis. So we must be alert. We must be studying. We must be really, really, really aware about what's going to happen with machine learning in the future. OK, so don't worry. This is fine. Nothing's happened. Everything's fine. So thanks. That was the talk.